Hi friends, welcome to Civil Architecture Tutorials. Today the subject is how we get electricity in our home from a dam, means from a power manufacturing power plant. So we know that if it is a dam, it is a hydropower plant because it is using water to generate electricity. So there are other means to generate electricity apart from hydroelectric power plant. The one is thermal power plant. Thermal power plant is where we are using coal as the main fuel. So when the coal has been burned in a very high temperature, it will convert. There will be water around that in a particular tank. This temperature will change the water into steam, and when the steam goes at high pressure and when it strike a turbine, the turbine will rotate and it will generate electricity. So that's the way the thermal power plant works. Same as the third one is nuclear power plant. We have nuclear power plants in India too. So in nuclear power plant, the fuel we are using is for example, uranium. Uranium is a radioactive component, radioactive material. So in which there will be atomic reactions happen. It will create a lot of heat, and the heat will convert the water into steam, and the same principle applies here also. The steam will turn at high pressure, it will turn the turbine and generate electricity. So this is the third one, the third power plant. And the fourth one is diesel power plant. Diesel power plant, as you know, as an example, you might know the small diesel generator in your home or in your office. When you give the diesel as fuel, it will generate electricity. So that is the fourth one. Then fifth one is wind power plant. Wind power plant, as you know, you might have seen big windmills when you are going through the road. If you are going from Kerala, when you are moving from Kerala to Tamil Nadu to Coimbatore, on the road, on the left side of the road, you can see long, very big windmills are there. So it will rotate as its own when there is some kind of wind activity there. So while it rotates, it will rotate a turbine inside it, and it will generate some electricity. So that's the principle, the same principle. Then comes the solar power plant. Solar power plant, for an example, we can look into the Nerbasheri airport, which is the Cochin airport, is fully functional by solar power only, in which there will be solar panels will be there, lot of panels will be there, which will be facing the sun, and it will take the light energy from the sun, and it is converted to electricity. It will be a DC current, and that DC current will be converted by a inverter to AC current, and from that airport is functioning. So this is solar power plant. And the next one is geothermal power plant, which is not there is no geothermal power plant in India, but there are a lot of other power plants in many other parts of the earth where the location is important. So how the geothermal power plant works is that, you know, the lava which originates from the earth's core. Earth's core is at very high temperature, we all know. From there the lava comes outwards, especially if it is in Indonesia. We have got a lot of volcanic eruptions. So there's a presence of lava there. So in such areas, if we establish this plant, we have to make a hole in the ground which will go deep into the earth up to a position where we will get the heat of lava. So they will put water into this hole. So naturally, as the heat comes into this water, it will change to water vapor. So the steam with high pressure will change a turbine and then generate electricity. The last plant, tidal plant, where we are making use of ocean. Means you know that there are a lot of tidal waves, high tide time and low tide time. Anyway, at that time the tide will come up and then the tide will go down. So there will be always a movement in the ocean. So we have to make use of that movement. So they will place the turbine inside the ocean in such a way that the turbine will rotate when it is high tide time, and when it is low tide time also the water will come down. That again it will rotate the turbine. So this rotation will again generate electricity. The principle is that we have to rotate the turbine with some force. So if it is natural force, we don't have to apply any other force. So we are making use of natural forces to rotate the turbine and thus generate the electricity. That is the principle. So these are, again I will tell, hydropower plant, thermal power plant, diesel power plant, wind power plant, solar power plant, tidal power plant, geothermal power plant. So now we will go into detail into the hydropower plant. Hydropower plant, as I said, there will be a dam which will make use of a river. This dam we will make in between a river, so that the flow of water in that river will be stopped for a while, and it will be converted to a kind of reservoir, so that the water will be stored at a height, so that the water has some kind of potential energy. And at times when we need the current, or when we have to generate the current, there is a sluice gate in the dam which we open. See, if this is the dam, we will open the sluice gate here. So from this sluice gate there will be a pipe called penstock pipe. Penstock pipe are designed such a way that when water comes into it, it will increase the velocity and the speed of that water inside. It will be the speed will increase by gravity only. So as the speed increases, the penstock pipe will direct the water to a turbine. So when the water strikes the turbine, it will rotate and it will generate electricity. So that is a power station in the dam. It will generate electricity. And this generating electricity is always 11 kV. 11 K means 1000. So 11,000 volt is the voltage of that generated electricity. So this is this turbine, 11 kV line is generated. Then, as we know, 11 kV, if we distribute it to a longer distance, it will lose its power, because if the transmission is to a very long distance, we need to increase the voltage. According to the Ohm's law, we need to increase the voltage. So there we have making use of a step-up transformer there. So once we generate 11 kV voltage from the manufacturing, the power plant in a dam, we have to step up the power with a step-up transformer. So it will, the 11 kV voltage will change to how much? 400 kV or 450 kV or 500 kV, depends upon the distance that this current have to travel, and also the load that is being generated by the dam. These two factors determines the power of transmission lines, high power transmission lines, how much power it can take. So let us, for example, we are taking 400 kV or 440 kV or 500 kV. It depends upon that. So this is the, from here, the step-up transformer, we are converting this 11 kV to 440 kV, 440,000 volt. And these you can see high tower lines or high towers. When we are moving through the national highways, we can always see there will be a lot of very high tower lines on the road, through which big thicker electrical lines are passing through. So this is called a high power transmission lines. These lines are called high voltage power transmission lines. From these transmission lines also we can take direct line to some factories. If there is a nearby factory on the way of these transmission lines, we can take direct lines from here to the factory. And in the factory, at least that means it's a high tension line. High tension, all the factories are using high tension lines only, because it is the load in the factory will be very high. The minimum load that a high tension consumer have to have is 100 kV, okay, 100 kilovolt. So once the power reaches the factory, they should have their own step down transformer there, and also panels to control this or change this voltage to the voltage that they need to function their activities there. So they have to convert that high power voltage to step down with the help of a step down transformer to a low power voltage. So that also can happen on the way of this high transmission lines. So, and from this high transmission line, it will reach a step down transformer area or a substation, which is also called powerhouse, at a maybe at some maybe 50, 60, 70 or 100 kilometers distance. So when it reaches that powerhouse, this powerhouse having lot of step down transformers there. So they will step down this 400 kV or 440 kV or 500 kV transmission power to 13 kV or 11 kV, it depends. Sometimes they change to 13 kV, and from there it may needs some more distance to reach our home, maybe 10 or 12 kilometers. So it may change to a 13 kV line, and after reaching 10 kilometers, then there will be a domestic step-down transformer on the side of the road. You can see there will be small transformers on the side of the road. So that is a step-down transformer. It will again convert. It will change this 13 kV to a bit smaller voltage like 220 volt or 440 volt, not kilovolt. 220 volt or 440 volt, which we are using in our house. Actually, there are two phases when we are measuring the current. There are two phases, phase lines coming. So one line is 220, the other line is 220. So it is 440 volt. Okay, so it's a 220 volt line we are using in our home. So thus it reaches our home. Okay. So once it reaches our home, this we can make use of this current to work. If there is an electric fan, we can make use of it, and for fridge, all these things, 230 volt to 220 volt we are using. But for making use of computer or laptop, we need the adapter which is coming along with the computer or laptop, so that this AC current will be converted to DC with the help of this adapter, and thus we are using laptop and all those things. So electronic devices, it has got its own adapter to convert this 220 volt to DC. Okay, so here this is the process by which the current that is generated in a dam has reached our house. I think you understand what I said. At least in a layman's concept, you understand how it reaches our home. So now we have to thank you, a person, for all this process. You know the name of that person, that is Tesla. Tesla is a person who founded the alternating current, and before that Edison did some work in the DC current, but that also, the DC current also has been modified by Tesla, because Tesla was an employer in Edison's factory, and after that he invented this AC current, and through him we all get this AC current. So without Tesla, we will not be in a position to have lights in our home, or the living conditions that we are having now is only because of Tesla. But Tesla doesn't get that much recognition when he was alive. Now the world has recognized his power, and we all are thankful to that great person. So by today's video, I think you understand the electric transmission from a dam to our home. I will come with a new video with a new subject. Till then, goodbye. Please subscribe, share and like my channel. Thank you very much.